Yo, what's up, everybody? Welcome back. Today we are working on writing a Wayland client from scratch, and today's topic is trying to get something drawn to the screen. So this is part of this bigger project of us trying to understand the Linux graphics stack, right? What happens when I spawn an application, I type glfw open window, and I get an OpenGL context? What does that mean? And like when I render to that OpenGL context, like how does it get from my window onto like the main screen? Like because on my screen there's like lots of windows, right? And for that thing that's rendering all the windows, how does that go through the Linux kernel and make it to the graphics card, right? These are all questions that we're trying to answer. So while we are kind of working on things that may seem disjointed, they are all to try to answer that one question. How does the GPU work, right? And so we've been tackling this from a few angles. We've been looking at like we did some like DRM Linux draw calls that like when you're in like your virtual terminal in Linux, like sometimes you hit like Control Alt F4 and you go from like a window that has stuff on it to just like something that has like text and only text. This is like a virtual terminal, and then you can like start like rendering stuff in here if you use like DRM directly. So we've kind of been playing like with that. We've been playing with the idea of writing like a PCI driver to eventually we want to have a virtual machine where we can like draw stuff with hardware acceleration on our own using the Linux graphics subsystem. So for part of that, we wrote like a PCI driver, right? So we made like a little virtual PCI card who had like a blinky LED on it. This is to try to understand that part. Eventually, we'll kind of like hook this driver up to do something like this. And we are currently working on the idea of how do windows, from at the highest level, how does like a window get populated with OpenGL, and how does that get onto the GPU and stuff? So that's what we're looking at today. We have been spending the last couple days on following this guide, essentially, called, can I scroll to the top, please? Learn Wayland by writing a GUI from scratch. I'm like, that sounds like something we would want to do. So we've been kind of referencing this thing. And basically this kind of talks about this thing called like the Wayland protocol. And so you might have heard when you're working on like just using your fucking Linux computer, you might be like, sometimes like I try to log in and it's like X11 or Wayland. What is Wayland? Well, Wayland, as far as I am concerned, it's like essentially nothing. Like it's kind of just like a language, but it doesn't actually like do anything, right? So I'm gonna have on my machine, I'm gonna have like kwin. So like everything that's on my screen right now is kind of drawn by like one process, right? And in this process, there might be like windows, and this window will like have like some stuff inside it. So if we're trying to draw a smiley face, what does that mean? And so like this process has like a socket, and this socket, you talk Wayland to this socket. And so like we make a client application, our little smiley face app or whatever, right? I guess we don't have the title bar. We don't know about the title bar. This is drawn by the compositor in this scenario. But basically we say like, hey, kwin, could you like give me a window, please? And here is some stuff I want to draw to it, is essentially what we are trying to accomplish. So what we have at this point is if we run our little test app, we see a little W show up in the bottom here with nothing drawn anywhere. But we have like managed to successfully communicate with this thing enough that kwin crashed. That's kind of funny. But we've managed to talk to him enough that there's a thing down here. I'm glad that the crash didn't seem so fatal that the stream ended. I think we're chilling. But yeah, we've got enough to like create a process that Wayland knows about, but not enough to draw anything. So this involved creating like a XML part or parsing the XML for this thing. Maybe this is a better example here. Turning it all into code that we can run. So we have like this, hold on, maybe if I foreground this, and we go into bindings, we have stuff that's like, okay, so the interface defines this interface called WLDisplay, who has a command on him sync, and we like auto-generate this code by parsing the XML, which is kind of fun. And then in our main app, we basically say like, hey, I would like to like initialize this app by doing something. We call like, hey, I want to talk to you, so please tell me all the interfaces you support. He gives us we say, hey, we want to talk to the compositor and this like XGG window manager thing. And so then when we get those back, we say like, hey, could we like create some shared IDs for these objects that like, so when I say I want to talk to number 4, you know that I'm talking about this like XGG WM thing. We create a surface I don't really know what that is yet. There is both a wayland surface and an XDG surface that have to be like tied together. My understanding is that XDG is kind of like more desktop-y things like window menus and title bars and stuff like that. And like the WL surface is kind of just like thing I draw to, is kind of my understanding at this point. And then there's from the XDG surface, we like bind that, I think, to like a top level surface that XDG needs to know about. Don't really know what that means. And then we like commit. And so today's topic is we're going to just keep going, try to figure out what's next. That is the plan. So we are at 0540. From experience, sometimes when K1 crashes, the pipe wire capture freezes and you have to select the screen and OBS again to fix it. Just heads up. It's fine now, but just something to be aware of. Okay, thank you. Big piece of info. Thank you. Okay, so let's go back and start looking at this guy's code. And he kind of talks about, we kind of made it to like, here he talks about creating a registry. We've kind of done that. We have not done anything related to a shared memory frame buffer yet, but I think that's kind of like getting ahead of ourselves. Here he's talking about chatting with the compositor. That's kind of where we're looking right now. So we've bound to interfaces. And he says we need a WL surface, XDG surface, and XDG top level. We have all of these things. He starts talking about reacting to events, pinging and ponging, as well as acting to configure events. So we have not really done this yet. So if we look at our output from our little run here, we do see that we have some configure calls. And according to this thing, it is very, very important for us to respond to these configure calls with an ACK. So if we look at like these configure calls that we're getting, unused event, like configure bounds, unused event, top level configure, unused event, surface configure, apparently it is important. So if we look at the XDG shell thing, he's going to have a configure message that is sent out by like the surface, right? The configure event marks the end of a configure sequence. A configure sequence is set on one or more events configuring the state of the surface, including the final configure event. Where applicable, surface roles will XDG surface roles will, during configure sequence, extend this event as latched state sent as events before they. Okay, I don't know what the fuck that means. We'll come back to that. Such events should be considered to make up a set of atomically applied configuration states. Okay. Clients should arrange their surface for new states, then send an ACK configure request with the serial sent in the configure message at some point. I remember seeing somewhere, I thought it was on this one, where the ACK is like not like an optional thing, but like required. Maybe it was on the top level configure. Clients must send an ACK configure in response to this event. See XDG surface configure and XDG surface ACK configure. So it seems like we kind of get like a configure event from the top level thing, followed by a configure event from the surface, and we need to ACK the configure event with the surface. The top level does not have like an ACK configure flag, and they also tell us to use the XDG surface ACK configure here. So I think that's kind of the next step, and lines up with what we see in this blog post, where if we look at his like code down here somewhere, we can look for like ACK configure. And he calls, yeah, he sees like if we got a surface event configure, we respond ACK configure, and then we go into the ACK configured state. And then he, in his code, kind of has a like, when I'm ACK configured, that's when I'm like actually allowed to draw shit. So I think all we kind of have to do here, is that, like, when we get an event, we should just be able to do like XDG surface. We get an XDG surface thing. Our lookup here is a little odd. So we need to kind of like do our bindings generator implements a like parser for a specific event, right? So if we know that we have a WL display event, we can call this like parse function to get a how do I call this? One of these event types out of it. But we do not have like a way at compile time to know what a WL display is, right? So what we do here is we have this like interface registry. Every time we bind a thing, we write to our interfaces, and we have like an interface registry that basically says, if given an ID for an object, which interface am I? Where interface just kind of says these things, right? So here we have to say like, okay, so we are a top level. XGG top surface, sorry, is the thing we're trying to look for. But now that we know that we're an XGG surface, we actually have to get the message out. So here we're gonna go like, let's see, event parsed, we'll call it parsed maybe, is going to be a wayland XGG shell bindings surface event parse. And we are going to parse this with our event header opcode as well as the event data. And this should give us everything we need. Now, this can give us a null. So in that case, I believe it will, let's see here a second, parse. No, it cannot give us a null. So we're kind of chilling here. Is Zig switch have same capability of match and Rust? Yeah, pretty much the same. Very similar. Very similar. Okay. So if we take our parse thing now, we're gonna like switch on the parse thing. And if we got configure, that's the thing we care about. So configure is the only option in here actually, which is kind of fun. So I guess we will just say we have to respond with this serial thing. So we have to do, we have to use our XG surface thing, our object, and send a ack configure with our writer. And we are trying to send some sort of ack parameters, which are just the serial that we got back. Okay. And I guess here we'll still debug assert. I guess we don't have to assert because this dereference of configure from this union type will assert in debug mode if this is ever not true. So we're probably fine there. We're probably fine there. Okay, let's see if that does what we want. So he's mad because this ack configure thing can fail. That's true, because we have to write to a socket. Writing to sockets can fail. And we do see that we send an ack configure params, and the wayland client doesn't get mad at us, right? So we can probably confirm that if we were to do something wrong here, still nothing happens. So that's not very good, right? We would kind of hope that, like in other scenarios, we've seen that if we send the wrong value, the wayland server will yell at us. But that does not seem to be happening here, which is a little concerning. But we're going to kind of hope that this is correct. Now, we still do not see a window of any type, which kind of sucks. But we will maybe just move on and see. Because maybe we don't see anything until we actually render something. That's a possibility. That is a possibility. Okay, so with this guy, what does he say to do? He says we should write to our frame buffer, to a frame buffer that is in some memory that can be accessed by both processes, the drawing process and our client process. To avoid drawing a frame in our application and having to send all the bytes over the socket to the compositor, there is a smart approach. The buffer should be shared between two processes. Nice. We need to synchronize the access between the two so that preventing the frame does not happen while we are still drawing to it. And Wayland has us covered here. First, we need to create this buffer. We are going to make it easier for us by using a fixed size. Wayland is going to send us resize events whenever the window changes, which we will acknowledge and ignore. Nice. This is done here just to simplify a bit of the article. Of course, in a real application, you would recess buffer. So he says, make a buffer to hold some client-side state. I don't really care about that. The window is a rectangle. So more what I'm interested in is like, is he just using like a shared memory ID? We will see. The window is a rectangle of both width and height, and we will use the color format XRGB8888, which is 4 color channels, each taking 1 byte, so 4 bytes per pixel. This is one of 2 of the formats that is guaranteed to be supported by the compositor per the specification. Nice. So stride counts how many bytes a horizontal row takes, width times 4. Okay. And so our buffer size is width times height times 4. We use single buffer again for simplicity, but also because we want to display a static image. We could choose to use double or even triple buffering, thus respectively doubling or tripling the buffer size. The compositor is none the wiser. We could simply counter client side. Sure, of course. Of course. Nothing crazy there. All right, time to really create this buffer. So here, what does he do? He does shm open and truncates the thing. It calls f truncate to get the size, I think. Is that what this does? Oh, he's trying to say set the size of this thing to the size that we want, and if that fails, we give up. Otherwise, we mmap that thing. Okay. So what is SHM open? I was kind of under the impression that you could that shared memory wasn't anything special. I was under the impression that it was just like I could use like disk-based shared memory if I want to, or tempfs, but I didn't realize SHM open was its own special call. So what is going on there? So this creates or opens a new or existing POSIX shared memory object. A POSIX shared memory object is in effect a handle which can be used by unrelated processes to mmap the same region of shared memory. The operation of SHM open is analogous to that of open. Name specifies the shared memory object to be created or open. For portable use, the shared memory object to be identified with the name of the form / some name. That is a null terminated string of up to name max 255 characters consisting of initial / followed by one or more characters. Sure. So yeah, what I'm more wondering is like, what happens when you call this? I guess that it probably just knows to make it in dev SHM. That would be my guess, because I was like very much under the impression that they were just normal files. What is special about SHM open? Is that gonna? Why use SHM open? Why not create a regular file? Yeah, that's my question. That's what I want to know. I've read the man page. The secret is in the mapping action. The file type seems to be meaningless. Any pointers would be good. If you open and mmap a regular file, data will end up within that file. If you just need to create a shared memory region without the need to persist the data, which incurs extra I/O overhead, use shim open. Such a memory region would allow you to store other kinds of okay, sure. So, but I was under the impression that if you just like, oh, nice. This is, oh yeah, baby. This is what I was wondering. So he just fucking sends it into dev SHM, which we can probably confirm by looking at like, I usually use Musel for this because its code is usually easier to understand than glibc. But it does look like they just call normal open where by prefixing dev SHM. Nice. Dude, that makes me feel so good where I'm just like, what the fuck? This doesn't make any sense. And it just doesn't make any sense. That's super cool. It's just like, oh, it is exactly what I thought. I guess they set some extra flags on it. But, you know, whatever. Let us make our shared memory object then. So I guess we will do this. Our initialization comes in like, our app runs in 2 stages. I have this like run event loop command or thing that I wrote that just basically like pulls shit from Wayland into a buffer. And then calls like this like app.update on thing. So we have like an initializing state where we're trying to basically like extract the interfaces that we care about from the Wayland server. And then we have like the normal running state. So I think in the normal running state, initializer is probably where we want to create this thing. We probably want to have like, you know, stud POSIX SHM. Oh, they might not even have it. Stud system stud OS Linux SHM open. Yeah, it looks like we should just do it ourselves with we can just use normal open. Can we look at maybe where do I want to go? I want to go to Zig standard library. SHM. Do I see anything in here? SHM, hello? They have stood C SHM open. But we are not, I guess we probably are linking against libc, so we could do it that way if we wanted to. But I think I don't. I think we want to get crazy. So I think we just want to go like dev SHM, and we'll call this like Wayland shared memory. And we probably want truncate equals true. I think that's actually probably done by default. It is. So we kind of just are happy to kind of go like try this. Then this gives us like a file handle, so we'll call this like shm file. Which we probably want to hold on to. I think. Because if we don't, then we can't close it. Then we probably want to like mmap this thing. I also think that we probably want to set some of those params that we saw in Moosel, right? So this was in like source. Oh, fuck. Hold on. So they kind of set these. Fuck. No, where do we paste it from? Fuck. I lost it. Unless it was here. Nope. Nope. I got lost. I'm lost again. Moosel. SHM open. This is in source mman. So we will copy to the system clipboard. And we will paste from the system clipboard. There we go. So do we have the options to do things like close exec and non-block in here? Are these things that we're allowed to do? Sets whether or not we will wait till the file is locked to return. If set to true, error would block will be returned. Otherwise, the file will wait until the file is available to receive. So this seems... advisory lock, none. Oh, so this is not like normal non-block. But also it's probably fine. That's probably fine. I guess we could like call like open ourselves. We could do like stood POSIX open. And we could probably like set the things that we want. You can set the flags later with fcntl as well. True. But I think I'm happy to just kind of do this. So stood POSIX system O. And I assume that everything in here kind of starts false. Looks like it. And then we can just be like non-block equals true. Close exec equals true. No follow equals true. And then we'll just say copied from Moosel. Okay, and then we will, this open takes in an O flag here. And what's the third thing? Perm. We can just say 0 probably, right? We'll see. Then we essentially just mmap this bad boy. Right, so we're going to say that we don't really, I think it's like we don't care where it goes. Or maybe that's the offset is the first parameter if I remember correctly. Adder is null and the kernel chooses the page line address to which to create the mapping. Oh sure, that's what we want. Then we want length, which is fine, that's simple. Prot, oh I guess we probably have to resize the file to the correct length or else the mmap will fail. We want prot, which is probably read write, right? And then we have flags, which we want shared. Share this mapping, so we want that to be visible to other processes. Okay, and then file descriptor and offset. Okay. So what are my options? I already forgot. Mmap length. So this is going to be the share buff size. So here we are probably going to have to do like fix me resize to buff size. But for now, we'll just do what they said was width times height. Buff width times buff height times 4 for 4 bits per pixel, right? So we're going to do const width is equal to 640 and height we'll do 480. And then this should be prefixed with buff. This should be const. And we'll just keep going here. So buff size, prot. So we had stood, POSIX, system, prot here. So we want like, how do I do this? Yank this thing, paste it here, and we'll say like const mmap prot. So we want read and write. Oh, this isn't wow, this isn't one of those fancy things. Okay. Okay, and then the flags was stood, POSIX, system, map is this. Oh, this one is one of those funny structures. So we'll say const map flags is this. Okay. Is it not called shared in this? They have called it. Oh, I think we saw this before. Was it sync? Man to mmap. Shared. Private. Oh, because private and shared were opposite of each other? Map private. No, he's not private. Hello? Oh, map type here. Ah, my bad, my bad, my bad, my bad. So this should be map type private, or shared, sorry. And then it was file descriptor. And whatever the fuck the last thing was, offset 0. All right. This needs to be called like a open O or something. I don't know. Whatever. And I guess we will see what happens. Unused local constant. Sure. So we'll stash the SHM file as well as the buffer. Okay. Okay. So this is now a stood POSIX socket T, and then we have the buffer, which is just going to be a U32, I guess, right? So this is good in order to do RGBA. So here we need to kind of do like a pointer cast of buff, which I think we actually do need to do stood mem cat buff as bytes as slice, I think. So we say, hey, we want this to be a U32 thing from 0 to buff size. That's what we want here. And I'm assuming this was not going to work. What's it mad about? Oh, this does take a map flags. Wait, where does map type shared go in then? Am I stupid? Yeah, map shared comes in here. Oh, I think there was a type thing on the map field. Yeah, it was type here. So we want const map flags is equal to stood POSIX system map flags. Hello. Type. Then that's this. Okay, there we go. This becomes map flags. Boom. Do we compile now? Okay. And I expect this will crash, which it does somewhere. He says, hey. Well, actually, he's just kind of leakies a lot. Oh, error file not found here. Right. Can we like disable the leak logs for now? I know it's like bad, but they're in my way right now. Right. So open. We probably need to set a flag that's like create. Okay. And then he has access denied. Really? Really? Am I not? Oh, it's here. So that's on, oh, that's on mmap. That's on mmap. So can we look at when it will return denied? E-access. Or file is not open for reading, or map shows request in prot write is not set, but FD is not open in read write mode, or prot write is set, but the file is append only. So here, probably this needs to have read write. Access mode, read write. Like this. Okay. Let's try that. No field name access. That's confusing. Ack mode. Okay, let's try that. He's still returning access denied, but this time on open. Probably because if the file already exists, does open fail if it already exists? Return value open as file descriptor. So he says that you can optionally create if create is open, or if it is appended, but where's like e-access here? Requested access to the file is not allowed, or the search permission is denied. Oh, where create is specified, the file already exists. So maybe I'm just supposed to use like create instead. Is that what I'm supposed to do here? A call to create is equivalent to calling open with flags equal to create, write only, and trunk. So maybe I probably need a trunk true as well. Oh, you put 0 for permissions. That's true. That is true. What are my, oh, that's mode. Okay. Which is just a U32. Okay. Oh, yeah, wait. So why is this different than... Okay, sorry. Flags. These are the flags. But then what is the mode parameter? It's been a minute. The argument flags must include one of the things. Yeah. Oh, but this is commented out, which kind of means that it probably doesn't do anything, right? I imagine that if I rm dev shm wayland, this will probably work. Yeah, so that's fine. And if I run it again, so it's still some problem with like, if the file already exists, it's like fucking up. Oh, you're saying it's this. Yeah, that seems likely, huh? That seems likely. So can we do like O 0 664 or something? 644? rm-f dev shm wayland thing. Zig build and run ls-l dev shm. Much better. Now I can run it again. There we go. Thank you. Good eye. All right, so we have our fucking shared object file. It's confusing to me that the mmap succeeded here. I would have expected the mmap to fail because we asked for size, right? Which is big. But it doesn't think that it has that size, which is confusing. So if I try to do, right, like buff 50 equals 4, is that going to segfault? Aha, it is. It is. So here we need to make sure that we've resized the file. So std posix f truncate. And we want to take the SHM file and set its size to buff size. Let's try that again. So this has happened here, I guess. There we go. Much better. Much, much, much better. Okay, so we have a buffer we can work with. Sick. Sick. So then presumably somewhere we like bind this thing. So what did he call it in here? He called it like SHM pool data, presumably, or I guess probably you transfer the file descriptor. So we're probably gonna look for uses of SHMFD here. And he sends it as auxiliary data on SHM create pool. So let's look at the docs here for Wayland WLSHM pool. WLSHM. So this is a singleton global that supports for shared memory, that provides support for shared memory. Clients can create WLSHM pool objects using the create pool request. On binding the WLSHM object, one or more format events are emitted to inform clients about the valid pixel formats used for the buffers. Okay, so I guess we would assume that we want to create a pool, then create a buffer, right? Presumably he creates a buffer as well. He does. So he creates the pool, he creates the buffer, and then he just sets pixels to this thing. Sure. He like writes the thing, and then he just calls surface attach and surface commit. Okay, we will look at that. So the flow here is expected that we create pool, then create buffer. So this means that in order to do that, we actually need access to the interface for, what was it? WLSHM here, because the pool is created by SHM. So we look for WLSHM, which means that in our initial state where we're looking for interfaces, we want to look for the WLSHM things. So here we're going to be like, yo, else if we see WLSHM, could we please make our WLSHM params equal to this stuff? I think all of this stays the same, which kind of indicates fix me. Should we factor out common code, question mark? Probably. We need to stash those WLSHM params, and then we say that we are not complete in our initialization step until that is set. Okay, so we need all of these things. Okay, then once we've found it, we need to like bind that thing. We'll call this params like this to match everything up. Which I guess also kind of means that this thing is probably going to have to get set wherever the fuck this is set here. Okay. Then we construct ourselves a WLSHM interface that we can work with. Sick. And this comes from the WLSHM params ID. Boom. We are so chilling. I kind of want these in one line, I feel like. Feels nicer to me. And then we have to define this thing as something that we have like an interface for. So I'm kind of confused about, did they put the interface for this up here? No. So do we just not handle display events ever? Like, what am I missing here? Interfaces or, sorry, compositor events? Yeah, I guess so. So we kind of fucked up here. We're kind of missing some lookups here, which is a problem. Well, eventually it will become a problem, but for now it's probably fine. So initializing app, we want initialized app here. So here we just need to make sure that all of these things have params interfaces dot put. We need the compositor ID. This goes to... Oh, I see. We just don't have this as an interface with support. Does WLSHM have something? He has a format thing. I guess we just will ignore this for now. Maybe we'll come back to it, but maybe for now it is fine. I suspect that we're going to want access to this thing later. Maybe not. Maybe we only need it now. Maybe. So what's the play here? We have WLSHM. We want to create a pool, which requires an FD parameter. And here we don't support that yet. So we actually, our auto bindings generator doesn't know what to do if he sees a FD parameter. And if I remember correctly, this FD parameter is actually set in some sort of like Unix socket auxiliary data is what I saw in here, right? They had like cmsg here. So I don't know what the fuck this is. I've never seen this before. So he has a buffer here. Where does this buffer come from? He uses an IO vector. He calls send message with this socket message. So socket message here is like this. And he has a control thing. A control thing. I see. So this is like, can we look at maybe in the Wayland book, or we should look at like the Wayland specification. They talk about this a little bit, I think. So they have like chapter 4 wire format here. The file descriptor is not stored in the message buffer, but in ancillary data of the Unix domain socket message control. So I don't really know how to work with this. But it looked like send message is the key. So can we look for like the word ancillary? That's not a thing that exists in here. But we can maybe look for message control here. No. Is there a C also in here? Send to, set socket. Man socket maybe? Maybe, no. Man 7 Unix, someone is claiming. I don't know if you're just fucking, oh, Unix is Unix sockets, I see. Okay, so can we look for like, what was it called? Message control. Okay. Ah, here he's talking about ancillary data. Okay, so this is, okay, when sending ancillary data with send message, so this is, okay, ancillary messages, here we go. Ancillary data is sent and received using send message and receive message. For historical reasons, the ancillary message types listed below are specified with a SOL socket type, even though they are AF Unix specific. To send them, set the C message level of the struct C message header to SOL socket and the C message type to the type. For more information, see C message. Okay, then one of these, security, credentials, rights. So none of these are really what I'm looking for, right? We're looking for something that lets us send, I guess, just like a generic file descriptor. In this example code, he wrote C message space. Then when he wrote the C message, he wrote SOL socket SCM rights. So, oh, here it goes. SOL socket, SCM rights, C message line. Send and receive a set of open file descriptors. Oh, I didn't read. I just can't fucking read. Open file descriptors. The data portion contains an integer array of the file descriptors. Right, so this, I guess, is like a special Linux thing that you can do because you're not actually sending like a file over the other side. It's like literally just a file descriptor, and like those are usually process specific. Okay, this makes sense. So we just use Stood POSIX send message, right? And we are trying to use this on our socket. So this is going to be the, I guess this is going to be the writer, which isn't really what I want. We kind of need like this. We don't have access to the socket at this point, so we're gonna have to get it. But we could also look at like a writer. Maybe instead of taking in a writer here, we just take in the stream. And the stream does have the handle I want. That does have the handle I want. So this now needs to be like stream is equal self stream. And here we need to take in, this thing takes in stream, 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 stream. Okay. And then presumably we use that thing somewhere in here. So this is gonna be like stream writer like this. Okay. Then here we're gonna replace this with like const writer is equal to params stream writer. Boom. And then anywhere we say params dot writer, this thing now needs to be just writer. Boom, 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 boom. Okay. And this is going to be, I guess now we are going to hold on to the stream again. I guess, theoretically, I don't know, we'll see. We will see, but now we can do like param stream handle like this. Did you actually send all the acts? If I recall, you just did one. Probably not. Probably not. Okay, so what is like a message header here? This is our message header. So here we'll say message header is going to be a stood POSIX message header const, I think, that's like its type. Okay, and the name is going to be the sock adder socklen. Oh, what the fuck? Why do I need to specify the sock adder again here if we already have a file descriptor? This takes a file descriptor. Okay. Confusing to me. Then what else goes into this thing? Control. So this is the thing that we want to set for real. Then the IO vectors. What a pain in my ass. We'll just look at what this guy did. So here he left those as null, it looks like. Right? He just kind of like didn't set those. The name and namelen. Which is kind of surprising that that's legal. Oh, I guess it does say optional here. So here we'll say name is equal to null. Namelen is equal to 0. Here we have to set our IO vec, which is just going to be one thing, but it supports having several things in it at once. So here I think we're gonna like do like IO vec is going to be a stood POSIX IO vec const. That's going to have some parameters as well. We will figure that in a second. For now, we will just write IOV and 1. Okay. Because we are not trying to write many things. We're trying to write one thing. Control, this is now where we wanted to get into the cmsg stuff. So it looks like we create a cmsg header. This must get sent to control here, buff. Buff is just this. Okay. Size of this thing, and then he must set the buffer somewhere. Buff, buff, buff. Am I crazy? Where does he put the FD in here? Oh, here. cmsg data. He sets that with here. Okay, Sure. So I think they said like cmsg cmessage for more. These are macros used to create and access control messages, also called ancillary data, that are not part of the socket payload. This control information may include interface that the packet was received on, blah, blah, blah. Okay, so they have a cmessage header like this. I don't really imagine that we really need to use these macros. I don't think. Presumably, we have like const cmessage is std POSIX OS Linux cmessage. Are we unlucky here and we don't have it? Man cmessage. So this is part of the Linux man pages, okay? And if we look at like Musil, can we look for like send message? This comes from cmessage header, which comes from probably syssocket. Okay, so this is just like a type defined in here. And then does that go into the kernel anywhere? Yes. Yes, it does. Yeah, this goes into like message control. So message control is from H. What is H here? Message header. Do we have a message header in our world, in our Zig world? Let's find out. Oh, we do. We do. What are we building? Just a Wayland client? Nothing specific? Yep. Yep. So I wonder if we're just like unlucky here and we don't have... we only have it under... Oh. Yeah, it looks like we only have this under like the C standard library bindings. So we might just have to use those. We might have to. Or we could just copy it. We could just copy it. Right, so this is a struct that has a socklan, level, and type, and then I guess the data is kind of like hidden as this like extra thing at the end. Do they have the cmessage data? No. Yeah, it's kind of tricky. This looks like not trivial to use from Zig, to be honest. What's the stack purely from scratch? Yep, purely from scratch. No lib wayland. No lib wayland. That's cheating. It's not allowed. Not allowed. Yeah, okay, so this seems like this seems like actually like surprisingly difficult to use this. So man 7 Unix. We are trying to set ancillary messages by using cmessage. We set the cmessage type to scm rights. And then we just don't, which means that we probably just have to get a little tricky here. So what's like the C API for this? We construct this thing somehow. Right, so this has like trailing buffer here, which maybe it's not supported here. And I assume that it's just like a buffer at the end. Here is an example of an array of file descriptors over Unix domain socket. So here they put ubuff, size of ubuff. And here, he just puts a buffer that is a union, Jesus, of the space here and struct cmessage header line. So I see. So the message header goes like in this buffer. Cmessage space must return like size of the thing plus the data buffer would be my guess. That would be my guess. So we probably want to do something like we want to do something like, sorry, I'm thinking. We're gonna have like C message header comes from stud C message header. Okay. This is going to be like aligned in the buffer. So we're kind of assuming that we have like trailing data here, right? So I guess we're gonna do, can you write it in C and call it in Zig? What's the fun in that? What's the fun in that? So here we want to like make a buffer that basically has these things in the front of it, with the data at the end. So in my mind, that kind of looks like const C message header is a struct, or C message is going to be a struct who's going to have like a buffer. And we're going to like allocate this thing, right? So we're going to be like, yo, I want to initialize this guy with this data essentially, right? This is what we want to push in, pass in. I guess we don't need, this doesn't need to be a class. We can just, because we're gonna, everything will kind of come in at once. So we can do like make C message. And we're gonna say, what? Let me think for a second. We're gonna take in data. And we're gonna return a buffer. Yeah. Yes. And we're gonna take an allocator as well. All right. I think I'm seeing something. So we're going to take this header and we'll say copied from stud C, and we can use with added 1 byte buffer on end. Okay. So my thought here is that we can use the address of this to figure out, like, I wonder if you can do like this. I wonder if this is legal in Zig. Probably not, right? Does Zig support C variable length arrays? Zig variable length array. Certainly not, right? Certainly not. Yeah, that makes sense. But I wonder if doing like, can we do, if we do like, oh, they're called flexible arrays? Oh. I think they're also called VLAs. I'm pretty sure I've seen, oh, this guy's saying that they're different. Okay, whatever, it's fine. I also wonder if you do like, you wait here or something, I don't know. We'll see how this goes. Certainly this is going to crash some shit. In fact, I think that probably we are going to want to do a test to make sure that this is like defined correctly eventually. So this is going to have to be pulled out later into another file for us to do some testing, but for now let's just do it here. Just kidding. We're going to do it source C message Zig. Okay, we're going to do this. Const stud is equal to import std const allocator is equal to stud mem allocator. Then we're going to be like pub function main void. We're going to call make C message with an allocator and with some data, right? Then we are going to call something. Let me think for a second. Var GPA is equal to stud keep general purpose allocator with I don't give a fuck parameters, and we have const alloc is equal to GPA.allocator. And then we're gonna say like print, stood debug print. This is how we're gonna start. Yeah. Okay, this is how we're gonna start. This is how we're gonna start. I've watched 2 minutes of your stream. I've unwittingly learned Zig. Oopsies. Okay. So this comes from POSIX, socklen-t. Maybe we do this to kind of make it like a little Zig type like. And we're gonna be like, sorry, I'm thinking. I guess we're gonna like create this structure. We're gonna create this structure, copy the data into the buffer. So we're gonna be like cmsg header, size of, yes, okay, plus data.len, right? This is what we're gonna make. This is what we are going to make. Now, probably if we had to make many of these things, we'd probably have to align, like if we would have to align them so that the next cmsg header is going to be aligned. Like we'd have to like add some padding at the end of the data if it wasn't aligned correctly, but we don't have to worry about that because we're only doing one. We're only doing one ever. So let's kind of see what this looks like. We do something like alloc u8s of this thing, but we need to allocate with the alignment of cmsg header. So we need to do like alloc with options, probably, who takes in an optional alignment and an optional sentinel. So sentinel is definitely null, but alignment is going to be align of cmsg header. Okay. Now can we do like we can do like as stood mem as value cmsg header from buff 0 to size of cmsg header. This should do what I want it to. So now we have like this. Now we can edit this thing. So we can say like header cmsg len is equal to data. We're gonna say like total len here is going to be this stuff. Hello, there we go. Which I'm not positive about here. We're gonna have to confirm this. cmsg len, total len, cmsg level. I guess this must be something that we pass in. It must be. Must be. Stood OS Linux send message. We can double check. I'm pretty sure that it has send message. Which takes in a message header const, but this message header const does not have like the cmsg control flags like implemented. You know? So I think we have to do it ourselves, which is kind of fun. What did it say in 7 Unix about level? Set the cmsg level of the struct to sol socket and the type to the type. So this is going to take level and type. So we're going to set the level, the type, and the type, level and the type like this. So now we need to take in the level of, I already forgot, sol socket, I think it said, right? SOL socket and the cmsg header to SCM rights. Level SOL socket and type SCM rights is what we're trying to do here. That's what we're trying to do here. So here, hopefully we have std os linux sol socket, nice. And then we have std os linux scm. No rights on here. Okay. Which kind of sucks. That kind of sucks indeed. So we probably have like std c scm rights. This exists. So I guess we'll be like wait, should we have just used I forget, did we check if std c had we didn't check if this has a send message in here, right? We did, but this came from this, which again we were just kind of stuck with control. Right? There was no like C message in here. Yeah, it wasn't. There was not. There was not. I guess we will pull this from std C from now. I'm okay with that. I am okay with that. Std C scm rights. We'll do it this way for now. That's fine. We will live. Then what? Then what? So now we're just trying to prove to ourselves that this is right. So if we get the level and the type in here, then we want to prove to ourselves that we can go like buff at header plus size of C message header. Yep. Onwards equals data. That's what we want, yeah. Invalid, oh, so this needs to be memcopy, I guess. And then we should be able to return buff. There's a chance, there's a chance. Great. Std C does not have SCM rights because this is in C Solaris. Great. Super cool. Super cool. Man. Okay, here's what we do. Here's what we do. We get Clang tools in our environment so we can have Clang D. So we can jump to definition on the same thing in a C version. So we'll copy paste the C version from here a little bit, just kind of like, you know, this part, kind of like this. Oh my gosh. Int main void. He needs a C message. So man C message, he gets a sys socket. Okay. And instead we're just gonna say like ASDF. So we're gonna do for here. C message needs a first header on a socket message. Whoa. Why? Can we like dodge that? Socket message, because he's just gonna have socket message dot message control here. Right, so this is just gonna be buff. This is just gonna be buff. So I think we can just call like car buff. Theoretically, I guess we don't really know. C message space of 4, right? That's what we're trying to make. This takes cmsg align len. Okay, plus alignment of the header. Oh. So he aligns the data to the length as well. He aligns the data to the length. Fuck, man. Do I want to do this? I mean, I've kind of like gone down the path far enough that we have to finish it, right? We have to. We don't have a choice. But this is annoying. So can we just kind of finish this off with a mem copy of cmsg data, cmsg with ASDF, right? So this is the dest, and then we need the length here. Right, that's kind of what we're trying to do. And memcopy comes from where? String.h. And here we're just going to be like, what does this do? This takes, if the control length is greater than or equal to this, he just returns the pointer to message control. Yeah, so there's nothing crazy to do here. So we can just call this buff. Which we cast. Okay, so we're hoping that if we do this, we get like the same thing in Zig and C. I guess it's kind of weird to me. I wonder why they couldn't get these macros in. Can you put this directly in C? Does Zig allow this? Yeah, but I wanted to see if we could do it in Zig. So what was I trying to test here? I wanted to know what SCM rights was. So this is... Does anybody know why they do this? This seems like so confusing to me. So they create an enum with SCM rights, then define SCM rights to SCM rights. Like this is defined does nothing, right? Am I crazy? This must match the definition in Linux socket.h. Yeah, okay, so I don't know why this stuff isn't in the Zig standard library. But we believe that this should be 0x01. And maybe our test will be to print out the buffer. Oh, so first of all, we need to make sure that we align this stuff. So I think that somebody was saying the other day, there's like a stowed library function for like aligning stuff. There's like a fuck align align forward probably round an address up to the next or current aligned address. The alignment must be a power of 2. Right. So here they said that they needed to do like data. I guess they did like an align macro, right? Right, when they did like cmsg data. Oh. Wait, that seems fine. When they did cmsg space, this required a cmsg align of len. So if I'm saying I have 4 bytes of stuff, they're aligning 4, which just takes the length plus a size t minus 1. Oh, so they're doing size t alignment. Everything is aligned to a size t. Right, so they're saying at least 8 plus cmsg header at least 8. I wonder why. I guess I do not understand this. I mean, we're so deep in it. We have to finish. So can we just like print out this buffer? So we'll do like open fopen comes from stdio.h. We're gonna open like test.c message. We're just gonna write this shit out. So we want like a wb. So we're gonna do like file star f is equal to this. Then we're gonna f write. What are my parameters to f write? Pointer, size, number, and the file. So we're gonna write like buff cmsg space 4 one of those cmsg space 4 things to f, and then f close f. Okay. So if we look at c message, what do we see? What do we see? Why not run translate C on the Moozle source code? Because this is more fun. Because this is more fun. I feel like sometimes you guys don't get it. Redefine. One reason is to ensure a macro is defined without worrying about redefining or change value. I see. So here, cmessage level is a int. This is an int. This is a size t. And this is a... So int, size t, is that what we're seeing in the thing? Size t, int, sorry. So maybe it makes more sense to do it this way. Size t, int, and then we're expecting to see the data. So if we understand this correctly, which we probably don't, I guess we don't really know. This guy used like C message first header. I forget what this did. Oh, this just pulls out the data of message control. Okay. So if we understand this correctly, which we probably don't, we should see 8, 16, plus 4 bytes. So 20? 20 bytes of data with ASDF at the end. Right? That's what I would like want to see here. But clearly there's the ASDF is not at the end. So this is padded. The data is padded to be 8 bytes, which explains the aligned thing. Because they're doing that so that the next C message header starts aligned at 8 bytes. I see. So in our Zig side, if we were to implement this ourselves, we would want to do like something that's like round up. We implemented this the other day, so we don't have to go through this pain twice. We have this round up function. Nice. So we're trying to round up const data len is going to be round up the data len to the alignment of C message header. That's what they're trying to do, I believe. Which means that the total length is going to be this plus data len. Then we are going to allocate this thing to total length. We're going to get the C message header right at the front with the alignment of the C message header. Right, then we just put the data here. Now, theoretically, we don't have to actually do that alignment at the end if everything is kind of lined up correctly. Like, but if we do this, we should get the exact same thing, right? So if we do this, and we just try to write this out, so we call this a zig C message, and then we do like an f, this has to be tried. We should get the same thing. Cannot assign to constant. That's true. Because does this not return a pointer? Bytes as value returns a pointer cast of bytes. So why Shouldn't this be fine? Should this not be fine? Cannot assign to a constant. Also, this is just not a valid thing to type. This is 0 plus size of cmsg header. But yeah, I'm confused about why this doesn't work. To be honest. Oh, probably, I wonder if this is a problem. I don't really see why it would be, but. Total length, oh yeah, I see. I probably just fucked up the types a little bit there. Create file absolute, or I guess we want current working directory, create file. And then write all is ignored. And then can we do like diff, binary, C message, and zig C message? They do differ. Okay, so C message looks like this, and zig C message looks like this. So we have majorly fucked up, huh? Majorly fucked up. So it looks like the size field here has gotten somehow set to 4 bytes here because the POSIX SOCLAN T that we have is a U32, but that does not match what we had in CLAN, which is a little scary. A little scary. So now memcopy arguments are of non-equal lengths. That's confusing. Is it bit size of over 8 or something? Is that going to behave differently? No? Okay, why? Why is this not the same anymore? Oh, because this needs to be, that makes sense because the padding here means that there's going to be extra shit at the end. So we need to do from the start of data to the end of data. So const start is equal to this. Const end is equal to start plus data len. Then we go from start to end. And then we run diff. They still differ? Can we hex dump C message? This guy is 18, this guy's 14, but the rest is the same. So it looks like our length calculation is wrong here. Oh, because the length field is not supposed to include the alignment, probably. So this is going to be like padded len. And this is going to be the unpadded len, which is going to be the size of the header plus data.len. So we'll call this padded data len to avoid confusion. Like this. Okay, and this should be called padded len here. And this should also be called, unpadded len. Okay, so now we have C message and zig message, diff. They're still differ? Oh, because we have, dude, okay, that's fine. That's fine. That's a fine difference. That's a fine difference. Okay, so now we understand how to construct one of these things, and fuck this, right? I think we've kind of gone through the fucking side quest, and I think this is not worth doing. There's like, this is just like scary and sketchy. Scary and sketchy indeed. And instead, we'll do this. We've had our fun. We've had our fun, right? And now we will do it right. So we will call this, that's good padding. Alternating zeros and ones of all instead of all zeros. Is that what the A is? That's kind of fun. That's a fine difference. You'll find out until the kernel until you find out the kernel expects those bits to be 0 to punish your assumption. Yeah, that's fair. Okay, we're just gonna call this like make fd transfer message c message, which will return a ooh. If we're gonna do this in like Zigland and we want the allocations to be owned by Zig, what we should probably do is return a size t here. That calculates the length here. So this is going to return a thing for a buff len of size t. So we'll say like get c message size space. This will return essentially c message space of buff len. Okay. Then what do? We do the equivalent thing. Make file descriptor transfer message. These things aren't defined in Zigland, so we'll just use them here. We'll do all the same shit, except we are going to take in the buffer. So buff already exists here. Is a wayland client the thing that the application used to draw to the wayland server, like X? The wayland client is a process that negotiates with the wayland server to get a window and to draw to it. So it kind of, yes, but it doesn't really use wayland to draw. It kind of draws itself and then tells wayland, hey, this is where I drew something. That's kind of like the idea, at least as far as we understand it. Okay, so then we need to have the then we'll call this the like buff, and we'll call this the data. We will mem copy from the data field of cmessage from data, and then I also guess we need like data len. And so maybe we'll call this data len too, just to be consistent with our naming. Okay. Okay, and then this will take data len. Okay, so then I guess we kind of also need to include cmessage.h, and we'll make source cmessage.h, and we'll kind of just take this, slap it here, and take this and slap it here. We'll type like pragma once at the top, and we'll put some semicolons here. And we'll include stdint or stddef. I think def for size t. Yeah, nice. Nice! Nice, nice, nice. Isn't this kind of like a fun little side quest? I'm having fun. Okay, so we should now be able to go into like our build zig, and we should be able to say that our program needs C source file. Right, and this is going to be like our file is this a lazy path or I think it's a lazy path. Source c message.c. Easy fix, easy fix. What was the main quest? The main quest is writing a wayland client. Our side quest is this c message bullshit. I think that we like the investigation of the zig side was probably mostly what we didn't have to do. Okay, and then I guess we will add to our like main zig a like const c message is equal to import c import c include c message.h. And in order for that to work, we need to have like our exe needs to add an include path to b path source for that to work. What are you writing the client for? Is it an end in itself, or do you want to write a program that uses it? Definitely an end in itself. We're kind of looking for a long-term project of how the fuck does graphics on Linux work? And so this is just kind of like one aspect of that problem, right? When I draw into a window in Wayland, what does that mean? Can I transfer GPU buffers between processes? If so, what's the lowest level API I can use to do that? You know, that's like kind of like the questions we're trying to tackle here. as well as like it's just kind of fun, right? I'm okay with kind of what's it called when you like do stuff that you didn't have to do, but it's fun because you learn. Whatever the name for that is. Yak shaving? Is that what yak shaving is? An apparently useless activity which, by allowing you to overcome intermediate difficulties, allows you to solve some larger problem. Yeah, I'm okay with yak shaving. Have you seen Looking Glass? Yep. Yep. Kind of, not really. Okay, so I'm using yak shaving wrong. Understood. Okay, so we're back to trying to send this C message. So our C message is going to be something that we say like C. Okay, let's try to get compiling again because we've kind of been all over the place here. If I zig build here, like what's our current state? How fucked are we right now? Yak shaving is when you want to write a Wayland client, but you remember you have to shave the yak first. Got it. So I think in order for stdio to exist, we need to link libc, or else he's not going to be very happy. But also, we don't need stdio.h. So you might be able to get away without that. But he's definitely going to need libc for string.h. So I think we're just going to leave libc linked. WLSHM unused local constant. Okay, that's fine. Is this supposed to go over here anywhere? No. Okay, so we'll comment this out for a second, or maybe we'll do a this for now. Then he's mad at right, we changed some shit over there at 389. This now has to be just stream. And then map type shared. Oh, so when I turn on libc, these like APIs change, which is a little bit annoying, but like fine. So does this still work the same way? Type shared. So here I was just, instead of doing this, I just write the dot like this, and it's fine. Okay, and then no field name writer at 355. So we're trying to stream dot writer. Okay, we build again. Do we run? It does look like we are running to at least the same point that we were before, right? We have, oh shit, crash again. Everything back. Okay. We still have created a window. It doesn't really draw anything, but we still have our window kind of shown up there. So we haven't like degraded too far yet. Okay, so we can go back now to trying to actually use this thing. So we had C. I want to make sure. So can I get my like C message dot? There we go. Get command space. So our data length is going to be the size of a file descriptor that we are trying to send over. So it's going to be size of a stood OS. I guess the size of type of SHM file is kind of what we're trying to send over. So then we will kind of like say that we were trying to make a thing of this space. We'll say like alloc this many U8s. I guess we also need to do this with the correct alignment though. So we'll call this buff. So why don't I have an allocator here? Params.alloc? Alloc.alloc? Do I not have an allocator? We can make one. We can make one. Okay. So yeah, we need to get the alignment of this thing too, I guess, huh? So we need to go into cmsg.h. We also want get cmsg align. And I guess we will say we just want like how do they do this? How do they do this in like man C message? They must allocate their buffer somehow. U buff, right? So they do a union here. So we'll use the same trick here. So can we do like, we have to do a buff of data len. And can we just like return a line of U? Is that something we can do? Man, a line of? C, a line of? Where does this come from? Is there a header that I need, or is this just like a built-in SCD line? All right. Then can we do like, oh, that's already there. And then here we will kind of comment this as stolen from man cmsg. This is, what a fucking stupid API, man. What a stupid API. Doesn't alloc have an alignment parameter? Yes, but we need to know what the alignment is. And it turns out that the alignment is not necessarily trivial. So we're just gonna copy what they do. So try this alloc with options. This is kind of a fun little game we're playing. Get cmsg align. And I can't remember. So it's lm, n, alignment, and null. All right, we fucking finally got there, I think. Buff is being redeclared, which is pretty fair. So this should be called like cmsg buff, I guess, for now. Do we compile? Comp time call of extern function. Fuck, man. It needs to be comp time? It has to? I guess we will just use the alignment of a C message, which must be comp time not known. Or we just get safe. We'll just write LOL has to be comp time. Hard to know. Hard to know without asking C. Check man C message. I guess we just write 8 here. Surely that's good enough, right? Because okay. We fucking finally got there. This is crazy. This is probably the hardest time I've had doing anything in Zig so far. But it's also kind of fun, so I'm not gonna be too mad. Size of data len would give size of size C. I know. I'm pretty sure. Oh, maybe I don't know. Yeah, maybe you're right. Maybe I'm an idiot. Maybe you're right. Maybe I am an idiot. No, because data len here is no. I knew. Oh yeah, here. You are right. This should just be like this. This should be like this. Fields must have a constant size, which means that this basically we just need to return. Okay, this whole function is fucked anyways. Fuck it. Fuck it. Fuck it. Fuck it. Fuck it. Fuck it. Should it be size of C int? That's what FDs are. But we don't know what the alignment of the C message header is. You know? You know? All right, so hopefully now we can kind of get this stuff kind of rolling. So control is going to be equal to cmsg buff. And the control len is going to be equal to cmsg buff len. And the flags, I don't know yet. I mean, where you put a hard code at 8. So the problem here is that the buffer maps to a struct cmsg header, which has like len, what was it? Type and level or something, then buff, right? So if this len is a U64, which it is for us, then 4 is not like sufficient alignment. So I'm just running 8 here because I'm like, surely we're never going to see anything that's like lower than 8 or like bigger than 8. Does that make sense? I hope that makes sense. I think 80% sure that you cannot just declare a static array of parameterized len. Yeah, I know. I made a mistake. You're right. You are right. Okay. Let's try to figure out how to make this IO vector now to do the thing that we're actually fucking trying to send. So we are just trying to send the data and len. Right. So this is just base is equal to address of the file descriptor that we were trying to send over. I forgot. It's been a while since we've actually tried to remember. Like, it's been a while since we've actually been starting this code, so I kind of forgot what it was supposed to be. And the len is the size of SHM file. The size of take a type. Yeah, it does. So type of SHM file. Then here we have get cmsg saves. Okay, yeah, I think we're chilling. What is this pattern? Underscore equals something. It just means like underscore is like a special rule for just like delete that shit. I don't care about it. So just like ignore it. IOV is the actual data, not the ancillary data. That's a good point. That's a really good point. Which means that we probably just do nothing, right? His IO here is certainly going to be like message. What is his message? Oh, the rest of the data. Oh, that's kind of fun. So when we're running this like WLSHM thing, geez Louise, man. Geez Louise. So what? Oh, fuck. What code was he calling here? It was when we try to pass the file descriptor. Which I think was on WLSHM. Create pool. Yes, so we were trying to create a pool with this file descriptor. And this is where we got stuck. So I guess that just means that if we see a file descriptor, we just dodge it, right? That's what we're kind of seeing in this. So he writes the ID in the pool size. And so, yeah, so he just writes ID pool size and skips FD. So we have to adjust our code generation that parses this thing. And if he sees file descriptor, can we just say like FD is void? If we see the type of FD, we write out void. Let's see just how fucked that is. So it looks like we did the code gen all right. And here, if we look for create pool, we do have a file descriptor of void in here, which is kind of nice for us. So it indicates to us as a caller that we have to pass this file descriptor, but like we don't know how to do it in band like this. So because this file descriptor thing is like fucking weird out of band shit. So in that case, we will do it ourselves. And so we have to create a buffer of the other parameters that we're trying to send. So which means that we have to do something like WL SHM dot hold on. Dot create pool. And we're gonna have to write the output to this thing instead of to our normal, like before we were just kind of like writing to the socket directly. We have to write this to a array list. Yeah. Jeez Louise. So call this like the WLSHM buff. And then we can call this with the buff writer with our parameters. So everything else we still have to set. So the ID is going to be like a new ID. Okay. And the size is going to be buff size. Okay. Okay. We're getting somewhere. I don't think you want void. There are events from the server that send you FDs that you have to receive, but we can't receive them in band. We can't receive them in band, so we don't really have an option here. I know that like we will have to get those things, but like if those things are coming in ancillary data, we have to just go out of band to get them. With the API we have now. So that's why I'm saying like there's an FD there, so it's to flag to us that like at least we know it exists. Oh, but there's nothing we can do about it. Because in this, what happens is like when we write the message, we iterate all of the fields of the structure, and so now we can do like void, just do nothing, right? Because the shit's out of band, which is annoying. So now we should have after this call a buffer here that we can use. So we can use like WLSHM buff items dot pointer and WLSHM buff items len. And then we should be able to fucking finally write this thing out. So send message takes in a socket and a message. And, you know, maybe we get lucky and the flags of 0 are fine. Missing struct field FD. So can we just write like FD is equal to nothing? And we'll put a comment like out of band. Okay, unsupported field FD at air union is ignored. Okay, so let's try this. Yes, but what I mean is that you want the fields of your struct to be cint so that you can use them as FDs. Oh. I see what you're saying. So because we don't know? No, because the file descriptor is passed in. I don't think that's true. I don't think that's true. Because it's not supposed to be serialized as part of the message that's sent in the XML. Or sorry, that's sent over the wire. Like it's out of band. It's out of band. Yeah, so we can retrieve it out of band as well. That's fine. I'm not going to implement this send message stuff in the generator. I'm not going to do that. Out of scope. Out of scope. I'm pretty sure I'm right. Like 60% sure I'm right. Which is pretty sure. Unsupported field FD at 205. Okay. So I thought we covered this, but I guess I must have missed something. So probably somewhere else, there's somewhere where he's looking at all the types here. So this also just does nothing for void. And that should do it. All right. 666. So expected type this, found that. So we need to do a pointer cast here because it's expecting a multi-element pointer, but we have a single element, but that's okay. I mean, we could also do this. We could do this. This would also fix our problem, I think. Where we say it's an array. Perfect. And then control len 335. We need to int cast this. Type of view size ignored. So I'm just gonna, I guess we say fix me check results. I'm not gonna fucking handle this right now. Thank God we built. And now he's mad at reach unreachable code at POSIX from 340. Okay, so maybe we need to look a little closer at the send message. What does he do? He does set the last thing to 0. He did set the last thing to 0. Last one. I know I meant that when you parse an event from the server, you can see a cint field in the struct, and you know you can be calling receive message. Yeah, I understand that. I understand that's what you meant, but I'm not going to do it because right now the readers and writers don't really know that they're working on a socket. Really, I was trying to avoid that, Maybe I'll come back to it, but like at this point, at the very least, I'm not gonna like integrate this into the binding generator. It's just too much. It's just too much. So I wonder what he's mad at here. Ian Val. Ian Val, are you? Fuck. No! No. Okay, let's bisect here. We have to do something here, right? So I think the easiest thing to do here is put null and 0 here for a second and see if that still fails. Obviously, the Wayland client won't be happy about it, right? But at the very least, maybe it will succeed, and that will bisect to us if it's broken. So here, it does look like he said, yo, I didn't get the right arguments here, but he did succeed. So it looks like that the E and val is at the very least somewhat related to this C message buff thing, which is kind of annoying because I feel like we did it all correctly here. Well, I guess we didn't actually put the stuff in the buffer. So, you know what? That's on me. That's on me. We probably do want to make the FD transfer message. So here we want to take in cmsg buff pointer, right? We want to take in our data, which is the int cast of, or the stood mem as bytes, shm file dot pointer. Oh, I guess we just can just do like this. And then they want data len, which is this. Okay. Expected 3 arguments, found 4. That's true. And this is not a pointer thing. And this needs to put an ampersand. And then he's mad because it discards the const qualifier. So can we kind of fix this by going into cmsg.h and making this data const? Okay, and then in cmsg.c, also making it const here just for consistency. Okay, expected error unit type found void because I did write try here for some fucking reason. There we go. We fucking got there, guys. We fucking got there. So we can tell he's not angry because, you know, he's not crashing. I wonder what happens if we like try to, instead of doing this, if I do like something stupid, like just kind of put like this, I wonder how like how much it blows up. Yeah, nice. Nice. So I think we're chilling. I think we're chilling. East const is best const. I do agree that East const is better. I kind of just put a random one there. I wasn't really thinking about it. But I think I do West const more anyways, just because the consistency of doing it what everybody else does is kind of worth it. Even though East const is better, I think that it's nice to be able to, like, when you're reading it, you see const car, that makes more sense to me, like, linguistically than car const. So I'm not going to ever get in a flame war, I don't think. You know, I'll just do whatever everyone else does. But if I were to pick for myself, I would do East const. East Coast, also best coast. Whoa. Let's not get crazy. Let's not get crazy here. Geez, Louise, man. So we sent our, we created our pool. So can we just like stick that into a function somewhere? I don't know where I want it. Like, I don't know, like up here somewhere. Function, create shm pool. And we'll just kind of copy out everything we made there because it's like too much there. It's just too much, man. What's that? BoJack Horseman? BoJack Horseman. Oh, fuck. Where the fuck was I? Here we go. So kind of just want like, what is like the API here? Create shm pool. And we're going to take in FD. Yeah. So we'll have like create SHM buffer. No, we'll kind of leave that stuff there. That's fine. I'm more worried about this stuff. Okay. And he's going to return, I guess, the ID that he allocated. Or maybe we'll take the ID externally. Okay, and an allocator. Okay, so we have like id.allocate somewhere. So this just becomes ID. And then this will be fine. Yeah, so here we can just call a create SHM pool with our allocator, our SHM file, and our WL SHM pool ID. So I guess we do like WSHM pool is equal to our wayland bindings WSHM pool with an ID. It's ID params ID allocate. Okay. Then we can pass in the shum pool.id here. And hopefully everything else just kind of works out. He's mad here about the SHM files to be FD here. Okay. And here he needs WLSHM to be passed in for an interface to work with. Makes sense. So this is going to be a stud. Nope. WLB, WLSHM. Boom. Cool. Buff size is missing. True. True. So that comes in here as well. There's a split here. And are we chilling now? When you program off stream to use such a large font size, fuck no, dude. It's impossible to fucking parse, dude. It's fucked. And I guess we take in the stream here as well. So where the fuck was this? Param stream. All right. Air union is discarded. Nice. All right. And size, buff size. Wait, he wants an I32? Fine. Fine. If he wants an I32, we'll give him an I32. And everything's still working. Thank God. And we can see sending create pool. Oh, I guess he says sending when we don't actually send, which is kind of funny. Because he's assuming that the writer that he's writing into is something that's sending, but we're kind of just, it's like kind of like just a generic writer. Okay. So we created a shared memory pool. Let's create a buffer now. So now we should be able to WSHM pool, create buffer into our writer. Do we have a writer right now? We probably should. Yeah, we do. And what does he take? This shit. So here we're going to say that we have like some sort of like buffer with an ID that we allocate. Okay, so this is going to be the WL buffer ID. Offset is going to be 0, surely, right? We're going to start at the beginning of the thing we mapped. The width is going to be buff width. Height equal to buff height. Stride is equal to buff width times 4 because it's in bytes. And format is going to be, he said we're going to do XRGB 888888, right? So XRGB, which is 1. Fix me, generate from WLGen, XRGB 8888. Okay. All right, dude. So now after all of this, I don't really know what should happen. I think that we should probably end up with a thing that we can write to now, but nothing happens. Nothing happens, which is probably good. So now all he did was he tried to just like dump some shit in there and attach it at the end of the function, I think. Right? It was something like attach and then commit. And that was kind of it. That was kind of it. So I wonder if we can just do that here or if we have to do it after we act. So I'm going to try just fucking running it here. All he did is yo. What are you talking about? Okay, so he attaches with some parameters buffer x y. So buffer must be the buffer ID. Then x is equal to 0 probably, and y is equal to 0, right? We're trying to attach this in the corner, I would assume. And then he wanted to commit. And I think the commit doesn't take anything. Yeah, nothing. Let's fucking go, baby! Oh, that's a fucking window if I've ever fucking seen one. Oh my god, dude, the payoff there is so sick because it was so fucking hard to do something so fucking simple. Okay. So now if we just do something that's like mem set buff like this, fucking make it white. Fucking make it white. Oh, U8s? Oh, yes, please. Okay, and can we make it like a color? So we're gonna do somewhere we could take this thing and turn it into a U32 buff. So we're gonna do this. We'll slap this up here. Const buff U32, and then can we do like a mem set of buff U32 to like 0xFF00FFFF or something? Change the color a little bit. Oh, yes. Whoa. What just happened? Why is it changing over time? What? Oh, it's probably faded out because I'm not responding to pings. This is probably the kernel doing the like gray out or Kwin. Sorry, the kernel, dude. What the fuck am I talking about? Kwin's probably graying out the window right now, which is very funny because it's not responsive. Yeah, there's something funny going on there. That's funny. It's because you aren't handling WM based ping. Yeah, I expect that's true. So we could probably just double check that. If we go into our update loop, we can probably register the WM base there as something. So I think we have like our registry here. We want our WM base. Oh, we do have XEG WM params. Oh no, that's bind. Yes, we want like params interfaces. Put params XEG WM params dot ID, and this needs to go to. Oh, we do have this. Is this used anywhere? I don't think it is. Okay, let's just see if we do this here. Do we get an error saying unused event? I got response for unknown interface. I guess we have to make sure we map them all. So compositor params is compositor. And then SHM params is WL SHM. We do have to kind of make sure all of these work out. So our interfaces So just to kind of like tie off the like what is happening in that like draw blue on the screen path, in case people were jumping in and out, we have opened a file in dev shm file. This thing, dev shm, is like a special file system where it is like temp fs. So this is just like basically backed by RAM. And so if you open a file in there, it's just like, meep mop, yeah, sure, that's a file, but the file isn't very like, it's just like backed by RAM, not a file system. And so if you like map that file into your process, you go like, oh, I will like make this file a grid of pixels, right? And we like color all those pixels in. Wow, they're blue now, right? This, we transfer the file descriptor with that like funny send message thing. We transfer the file descriptor over to like the compositor, and he now knows that he can render that. That's essentially all we've done. But it was a pain in the ass to do that. We do have params interfaces put xggwm base here, which is who should have the ping. But then I don't see that in a log here. Oh, here, unused event ping. I missed it. Right, so here we can handle that event if we do, we got xg wm base. We are going to parse the event that we get from that thing as a xg wm base event. We are going to see what are our options here. There's only ping. So we are going to say try self xg wm base pong to indicate to this guy that we are still ready to rock and roll. And we'll just pass back the thing that we got. So this comes from parsed ping serial. And hopefully that stops the window from turning white. So we hold off. He stays blue, baby! He stays fucking blue. Okay. All right, that was a fucking disaster. And I did not anticipate sending a file descriptor to be so fucking difficult. But you know, other than that, I mean, it was fun. I'm not gonna like complain. Like it was a disaster, but a good disaster in my mind. So I think we call it there, because it is past 4 o'clock. So this is a good checkpoint, I think, for us to say we did something today. It's exciting. It's cool. And we'll call it a day there. So, message, you can use memfd create instead of shm open if you don't want to deal with all that bullshit. Interesting. So instead of creating the file directly, this is probably man3, memfd create. Oh, this is just like a straight up syscall. Cool. So now you know this is probably better, because it shouldn't, like, this means that you don't have to actually have it as a file, just like a path somewhere. So that's pretty cool. Okay, sorry, distracted. Yeah, guys, thank you for watching. If you like what you saw, we stream most days at 12:30 to 4 o'clock Pacific time. If you are watching right now or on YouTube, you are seeing the 2 to 4 segment, which we usually call mainstream. There's also a 12:30 to 2 segment that we call happy hour. These get archived on Patreon and YouTube member videos. So if you want to check those out, we kind of do like less focused, more like exploratory or like bug fixy or like cleanup work in those streams. So today we were looking at how does virgl send commands for hardware acceleration in a virtual machine from Mesa all the way over to the renderer on the client side. Yesterday we were doing some cleanup on some of the XML code gen stuff we were working on for Wayland. So if you always want to see that type of content, that is available. Otherwise, do the typical streamer like, subscribe, Twitch Prime shit. And I guess that is it. I guess if you're watching on Twitch, there is a YouTube link in the Twitch description where you can check out our previous work for the main show. And there's a GitHub link where this code will show up under this Wayland client stuff eventually. All right. Thank you for watching. YouTube, goodbye. And Twitch, let's find someone to raid. I have to wave with my left hand because I need to click this stop recording with my right hand.